Hello, everyone. Thank you for joining us for this webcast presentation on Northwest forests and carbon. My name is Aaron Robertson, and I'm the Communications Manager for Oregon Wild. I want to give you a little bit background about how this came to be. This panel was supposed to happen at the annual Public Interest Environmental Law Conference at the University of Oregon Law School in Eugene, moderated by the Many Rivers Group Sierra Club. But that conference was canceled. But that opened up an opportunity to reconceive this as an online presentation that could reach many, many more people than that PILC conference could. So hence this webcast. A video of it will be emailed out tomorrow to everyone who's registered. If suddenly your screen freezes up or you lose the presenter slide deck, try closing completely out of your browser and then rejoining using the event link that you should have had emailed to you about an hour ago. If you're on mobile, you should be able to control your screen, how big you're seeing it, who's talking, and whether you can see their slide deck by tapping, and that should give you some control. Now, as a brief overview of our program, we'll have 3 presenters. Each one of them will give a 10 to 20 minute presentation. Our first presenter will be Dominick DellaSalla. He's the president and chief scientist for the Ashland-based Geos Institute. He's the author of 200 technical papers on forests, fire ecology, and conservation biology, many of them relevant to the role forests play in global climate change. Following Dominick, we'll hear from Ernie Niemi, an economist and consultant specializing in applying the principles of cost-benefit analysis, economic valuation, and economic impact analysis to describe the importance of natural resources. His work is focused on the social, economic, and natural resource impacts of the timber industry and climate change in the Pacific Northwest. And lastly will be my colleague, Chandra, LeGue, the Western Oregon field coordinator for Oregon Wild. For the past 16 years, she's been an advocate for Oregon's public forest lands, waters, and wildlife, working to engage the public and influence government agencies and elected officials for better forest management. After these presentations, there will be time for Q&A. You can enter your questions at any time using the question box off to one side on the webcast interface. Those questions will go to me to ask our panel. We do have several hundred people signed up for this presentation, so we probably won't get to every question. I'll try to pick those that appear to have the most interest. I'm going to ask our panelists to introduce themselves again at the beginning of each of their presentation for folks who may join late. And with that, I'm going to turn things over to Dominick.
Okay, just getting my screen up here for folks, assuming everybody could see my screen there. Hang on a second. Still dealing with that. Here we go. Good afternoon, everybody. My name is Dominick DellaSalla. I'm the chief scientist for the Geos Institute in Ashland, Oregon. And the work I do is at a global scale. I'm part of a team of scientists working globally to quantify the ecosystem and carbon benefits of the world's last remaining primary or unlogged forests. And I've been working with scientists in Europe, Canada, the United States, and Australia, and in the tropics. I'll focus on the US today, but keep in mind that a lot of the work that I'm doing here has a global emphasis as well. We've been trying to guide the European Parliament in making decisions that are similar to what you're going to see today that apply to forest, carbon, and climate. And the last few days, I've been spending Zoom congressional briefings that have been organized by the John Muir Project to present a lot of the same information that folks in Europe, in Canada, the US, and Australia are seeing on this talk today as well. So this is truly a global presentation with a zoom in on our region. So there have been a series of warnings that have come out recently by the scientific community, some of which were organized by Bill Ripple out of Oregon State University. I was one of the 20,000 plus scientists that signed on to the second warning of humanity. I was on the first warning that was issued during the Earth Summit in 1993. We knew there was a problem back then. Years later, we're facing a countdown. And that countdown is a ticking clock. And by most scientific analyses, we've got about a decade until we really start to see severe climate impacts. The same thing with biodiversity. Another warning was issued. The United Nations released a report that 1 million species were headed for extinction. And we lose the biodiversity of the planet, it affects the atmosphere. It's all linked. Biodiversity is not a victim of climate change. Biodiversity is the solution to climate change. And that's what my talk is going to be about today, how to get the planet out of the mess that we're in. So forests are a key solution to carbon pollution. How's that for some poetry in my science? And based on the latest studies, we can easily just simplify forest as the lungs and the water towers of the planet. And you see some of the statistics there. It's really striking. And we've known for quite some time these primary forests have a lot of biodiversity benefits, but now we're finding out that they hold the keys to our climate future. And the most important part of these forests is actually in storage and flux. You hear a lot about net sinks, sequestration, but it really comes down to how much carbon we can store in those forests over time and keeping carbon out of the atmosphere or flux. Those are the two main considerations. So when you hear industry say, we've got a net sink or we're doing sequestration, that's only part of the puzzle. The most important part is storage, long-term in forest, and keeping carbon out of the atmosphere. And primary forests do it the best. Our unlogged forests store 30 to 70% more carbon than logged forests based on global studies that have data from all over the world's forest, temperate, tropical, and boreal. And if we protect those forests, we get a basket of benefits that come with water, air quality, soils, pollination. The whole basket of ecosystem benefits and biodiversity are coupled with carbon. And so here are the choices that we face. So the connection here again is between the biosphere and the atmosphere. There's a feedback system at a global scale and at a regional level. And so, for instance, if we choose to keep carbon in the forest, then forests can mature to become old growth, and they continue to sequester for centuries as they store carbon long term. Interestingly, it's the largest trees in those forests that store more than 50% of the carbon in those forests. So that's where we need to go. The other side of the figure is sending carbon up to heaven. So John Talbert actually coined the term sequestration dead zones, which after logging, those areas that have been logged don't start to sequester again for over a decade. The other important thing to consider is you hear a lot of the industry talking about, well, we're storing carbon in wood product pools. That's true. However, 65% of that carbon was emitted when the forest was cut down. 19% of the products go to the landfill pretty quickly. Only about 16% winds up in long-term products that only last for a few decades compared to the hundreds of years in the original unlogged forest. So what we like to use is a leaky bucket analogy. This is from Mark Harmon. It's also been called catch and hold compared to catch and release, John Talbot's work. Slow in, fast out, Bev Law and Tara Hudeberg's work, that carbon enters the forest slowly and is released quickly through natural mortality or logging. And we'll talk more about which one causes more carbon to leave the bucket, mortality from natural causes or logging. So as I mentioned, only 16% of the carbon from the forest winds up in the wood product pool. And then as you move carbon to different places in our economy, you're using emission or you're emitting fossil fuels. contributing to more emissions to the atmosphere. So it is a net loss by taking carbon out of the forest, both in boundary at the site of where logging occurred and out of boundary through shipping, manufacturing, and burning woody biomass. All of these products are a cost to the forest ecosystems and the atmosphere. That cost plays out at scale. Carbon leaves the forest quickly, as mentioned, 65% of it when the forest is cut down. So you're starting out with that block of carbon in the live tree, and you're starting to cut into that by taking it out of the forest and leaving slash behind and root wads and damage to soil. You're emitting an awful lot of carbon. Then you've got the stand level. So when you take a primary forest that's carbon dense, you log it, yeah, the trees are going to come back, but you've already created this carbon debt. And that carbon debt is never replaced because of reoccurring logging that takes place, especially if it's an industrial landscape. So there's the loss at the stand level. And when you start to add it up, you start out with a lot of carbon on the left, and you wind up with a lot of carbon on the right going into the atmosphere, creating that carbon debt that we see in industrial timberlands. Thinning also removes carbon. Again, carbon goes into the forest slowly through the process of photosynthesis, and it comes out of the forest quickly when we take trees out. And you never really recapture that carbon because the trees just don't come back to what the original forest was. They're thinned again, they're logged again, and there's some of the data from Mark Harmon and Bev Law's studies showing the loss of carbon even in thinned stands. Then you've got the landscape leakage, which just accumulates the loss of carbon over space and over time. So I mentioned that we would look at emissions, and this slide shows that logging emissions are far greater than emissions that are produced by natural causes. We hear members of Congress and decision makers talking about fire and insects all the time, but you can look at the statistics there in the terms of the amount of carbon loss on a county by county basis across the US. Most of that comes from logging forests. And we really need to turn this thing around so that we're not turning our forest into the equivalent of smokestacks. And the only way to do that is to avoid additional emissions and store more carbon in ecosystems. We hear also a lot about wood as a natural climate solution. And yes, wood does have carbon in it, but keeping in mind only 16% of that carbon from the forest is in the wood product. The wood substitution issue instead of concrete and steel has been grossly exaggerated. There's product leakage just because wood is not being, or concrete or steel is not being used in a building, doesn't mean it's not being used elsewhere. And forests store carbon for centuries, buildings maybe for many decades. And what really comes down to is the need to do a life cycle analysis. Okay, a few other slides and then I'll wrap up. But the thinking that we've been doing is producing these maps of carbon dense forests in the United States. As I mentioned, part of the work I do globally is also focused in the US. And we're now creating this next generation of maps. We did this back in 2014 using data from 2000 year 2000 carbon inventories. We're now in the process of updating this. Those dark green areas that you see are the carbon sinks of the US. We're proposing a natural carbon reserve to get the US back in the game on the Paris Climate Agreement and capturing all the old forests greater than 80 years, all the large trees, and this is really important. In some places, we don't have old forests, we have large old trees. Remember, they capture about 50% of the carbon in the forest. We're seeing a threat to this right now with the forest plans in the eastern Oregon talking about removing protection for large trees that instead should be in this natural carbon reserve nationwide. Not all forests are created equal. Here are the carbon density values for national forests, the top 25 in the US. Notice the Tongass rainforest at the very bottom. The roadless areas in particular are at risk right now on the Tongass, and they contain about 10% of the nation's carbon are in those forests alone. So we've got to get those into a natural carbon reserve. So here's the choices again. I'm wrapping up with these last 3 slides. The choices we face. If we continue to treat forests as smokestacks, we create the carbon debt for centuries. We have sequestration dead zones. We have out-boundary emissions. We have cumulative emissions in boundary, and all the other problems that come from putting more carbon into the atmosphere. Also, the dirty air that we create intensifies pandemics. We can talk about that later in discussion. The alternative is this natural carbon reserve, tying up the primary forest, the mature forest, the large trees into a reserve network across the country. Doing proforestation on degraded forests allow them to recover their carbon stocks over time. That means maximizing carbon in wet forest, optimizing carbon in dry forest. You might be able to do some thinning from below small trees and still optimize carbon and create this system that would make our air quality and our climate more conducive to a healthy human ecosystem, as we're learning through deforestation links to global pandemics. And here's what the whole strategy looks like. So wrapping up, we've got 10 years to avoid climate chaos. A natural carbon reserve would keep atmospheric carbon in the forest and dino carbon in the ground. We would get a basket of services. There would be the biodiversity atmospheric feedback system maintained. We would have also other benefits like connected landscapes and reduced stressors. And we would look for incentives to plug the leaky bucket through offsets, conservation easements, and proforestation. So I'm going to stop there and turn it over to my colleague, Ernie Niemi.
Thank you, Dominic. I'm Ernie Niemi. I'm president of a consulting firm in Eugene called Natural Resource Economics. I'm also a co-director of an organization called the Forest Carbon Coalition. We have about 70 organizations across the US. All of us are interested in developing strategies and implementing those strategies at the state level and at the federal level to increase the amount of carbon that's stored in our forests. You can see that my pictures aren't nearly as pretty as those that Dominic has, and that's just part of the burden that I have to bear by being an economist. Okay. This is what I want to talk about. On the far left, at the bottom, you have logging generates carbon dioxide. Dominic talked about that. You have climate change. And then on the right side, you have multiple ways in which that carbon dioxide generates economic damage and poses costs on the rest of society. Some of them are direct. We see that the carbon dioxide and global warming can cause disease, injury, and death. Some of them are indirect, in that we see that our economy slow down, we see lower incomes, and we see governments becoming more stressed. So let's begin at the bottom left. And why do we have so much logging in Oregon? And the answer is really pretty simple. The landowners, the people, the corporations who own about 6 million acres in Oregon, by my calculation, these people don't reveal the information, but by my calculation, they earn profits of about $1 billion per year off of those 6 million acres. they earn additional profits from logging on public lands. So bear that $1 billion in mind for a little bit. We'll come back to it later in the presentation. Then how much carbon dioxide do logging operations in the timber industry emit? Dominic talked about the various ways in which those emissions occurred. This graph, which comes from High Country News, shows the major categories of carbon dioxide emissions in Oregon. The timber industry on the upper right generates about 35 million tons per year. That is the largest single source of emissions in Oregon. Larger than the upper left, which is transportation, that is to say the direct burning of fossil fuels in trucks and automobiles. Now, although there are two studies, very good studies, that document the timber industry's emissions, there seems to be a lot of uncertainty and confusion about how much these emissions are. And a lot of people actually believe that there are no emissions from the timber industry at all. And from my observations, the reason for this is that the timber industry and many of its supporters seem to be following the playbook that the tobacco industry developed many years ago to provide false science, fake science, bad science, as well as slick messages that create confusion and cause governors and legislators and members of Congress in Oregon, the Board of Forestry and the Oregon Department of Forestry, cause confusion about what are those true emissions from the timber industry. I think Dominic has demonstrated very clearly that those emissions are very real, but yet we seem to have this confusion. So let me talk about three of these, because I think you can't fully appreciate what the damages are if you can't get past and if you can't help others get past the confusion that exists there. So here's one of the deceptions that we see, and that is that logging is carbon neutral, or that it is sustainable. This is actually a photograph from one of my neighbors cut down a tree. It wasn't for part of the timber industry. They had some threats coming from that tree. They cut it down. It was about 45 years old when they cut it down. But think about it. The industry had cut it at 20 years, which is indicated by the line on the left, planted a seedling, and then they say that after 20 years, they could cut down another seedling, another tree 20 years old. And so they've replaced what they cut down the first time, and it's all carbon neutral and it's all sustainable. And how can anybody, how can the governor, how can legislators be opposed to that? How can they try to rein in the timber industry's emissions if it's carbon neutral? What a wonderful thing. The thing to notice, though, is that if you have one circle for a 20-year-old tree and then a second circle for the 20-year-old tree, that doesn't even come close to covering all of the carbon that would be stored in this tree, was stored in this tree when it was allowed to grow 40 years old. And as Dominic explained, even within the 20-year-old circle, that 20-year-old tree, only about 16% of it would have ended up as timber products that keep carbon out of the atmosphere for any period at all. And that doesn't take into account the out-of-boundary emissions that occur from shipping logs and from shipping timber products. So what's the real way, from an economist's perspective, to calculate timber emissions? And the right way is that you add two components: the actual emissions from the industry. So when they cut down the tree, at least 2/3 of that immediately or very quickly goes into the atmosphere. After a short period of time, more of it goes into the atmosphere, another 20% or so. In addition, you have to take into account the carbon that the tree was not able to continue to pull out of the atmosphere if the industry had not cut it down, but instead had allowed it to grow. When the industry describes itself as being carbon neutral, it totally ignores the second of those. And then it sort of blinks and dismisses a large part of the actual emissions. And then Dominic talked about this one as well. It's another deception. that wood is much less carbon than steel or concrete. So the industry and its supporters sort of concede that, yeah, cutting down trees emits a little bit of carbon, but it's so much less than steel and concrete. So if you can substitute timber for these other materials, then it's a great deal. This argument sort of reminds me, actually very strongly reminds me of the arguments from the tobacco industry over the years of trying to sell cigarettes that have low tar and low nicotine, trying to get consumers to focus on low rather than the fact that those cigarettes still had carbon, still had tar, still had nicotine, and still killed people. And as Dominic pointed out, the studies that come from the industry to support this assertion exaggerate the much lessness of substituting wood for carbon by up to 100 times. And then here's the third deception. The industry and many of its supporters sort of baldly say emissions don't matter because, well, they're jobs. And in particular, the timber industry generates jobs for communities in rural Oregon. The graph, which comes from the Oregon Employment Department, shows that the jobs per million board feet, that's MMBF, so the jobs per million board feet harvested in Oregon, in other words, the jobs per log, have declined very steadily for more than 20 years. So they used to be up around 13 jobs per million board feet. They're now down around 6. And it's important to look at the right-hand side of that graph, and the blue line, and see the sharp decline that occurred after 2008. So as the industry recovered from the Great Recession of the last decade, at the end of the last decade, they returned to their level of output, their level of harvest, about 4 billion board feet per year. But as they returned to the same level of output, they cut their jobs by 1/3. If you look over the long term, the number of jobs that the industry has cut, it averages out to about 1,000 per year, over 30 years. They also have cut wages, not in an absolute sense, but in the past, when labor unions were strong in this industry, those unions were able to demand higher wages than workers in other industries. If you go back, that premium used to be about 30%. By the 1990s, it was about 20%. If you look at what has happened since then, the owners of the corporations that own this industry have pulled that money back out of the pockets of workers and put it in their own pockets. The average per worker still in the industry is about $15,000 per worker that the industry corporate owners have pulled out of the workers' pockets and put into their own. So now let's look at the right-hand side. Now that we have some context for thinking about this, what are those carbon costs that come from the timber industry's emissions? Well, economists, you have a term for this. They call it the social cost of carbon dioxide. That is the cost that carbon dioxide imposes on society, or the social cost. During the Obama administration, they worked very hard to try to estimate what these costs were per ton, that's spelled with T-O-N-N-E, so it's a metric ton, per ton of carbon dioxide. And in 2010, they came up with the estimate of $10. There was a large outcry from most economists in the country saying, you just ignored so many things. So they went back and did it. They were being very careful because by the end of 2010, the Republicans controlled much of the Congress. And the economists doing this work were afraid that they would be attacked. A sort of a precursor to what's going on today. So in 2016, they came up with another estimate of $40 to $50 per ton. Again, the economists who put this together acknowledged that they were leaving many, many, many things off of the table. Nobody included, for example, a pandemic that's related to climate change. Nobody acknowledged or even pretended that they had all of the costs that come from ocean acidification and warming of the oceans. Well, in 2017, the Obama administration was gone. The Trump administration said the social cost of carbon dioxide as zero. In fact, let's pretend that it's really good for everybody to have more carbon dioxide in the atmosphere. And so some economists and scientists, top-level people in 2018, prepared another analysis and came up with $417 per ton. So we've gone from 10 to 417 in 8 years. Again, trying to pull in more things, more of the direct costs and more of the indirect costs that I described in the earlier slide. It's important to recognize, however, that these are expected damages. These are the damages that the climate's models tell us we should expect to occur if everything turns out as the models expect them to occur. But Dominic touched on this, and over the last 2 years, we've seen a flood of reports and warnings from the UN and other places that climate damages will be bigger than expected. Diseases, sea level rise, places are already becoming uninhabitable because they are too hot and too humid. We're seeing extreme drought being predicted sooner than expected for the southwest of North America. And Dominic talked about ecosystem collapse, and there's much more. So instead of talking about $417 as the damage per ton, it would be prudent for us to look at what the cost would be if the damages from climate change turn out to be bigger than expected. Anywhere from 2 times, or about $800 per ton, to 8 times. And I didn't make those numbers up. Those numbers actually come from some of the research that has been published out there. So $800 to $3,300 per ton. So let's go back and look. The statewide total of 35 million tons of carbon dioxide, if the social cost of carbon is $417 or expected, then those social costs are $14 billion. So if climate change turns out to be sort of, gee, the best case that we can expect, the damages imposed on society from the timber industry will be $14 billion, or 14 times the $1 billion of profits that landowners receive. But then the next 2 columns show us that if disasters prove to be 2 times expected, those social costs will be $27 billion. And if it's 8 times expected, it'll be $110 billion. And by the way, it would only take, say, 1 more pandemic occurring in sometime in the near future for us to exceed that 8 times expected. Well, I don't know about you, but I've never seen $110 billion. I've never even seen $14 billion. It's hard for me to wrap my head around that. But one of the things that economists have done for a long time is wrestled with the notion of what happens when we have activities that kill people. And in the United States, economists have estimated that when we have an activity that is going to kill somebody sometime in the near future, that cost is about $10 million per death. And that means that these costs, these social costs measured in the billions, are equivalent to 1,400 deaths up to 11,000 deaths every year if the timber industry in Oregon behaves as it has in recent years. Now, I have pluses in there because other countries don't value their deaths at 10 million per death. It's a lot less. The IPCC uses $1 million, for example. So if you wanted to convert $14 billion into deaths using the IPCC's numbers, that would be 14,000. And over on the far right, that would be 110,000 deaths per year. Well, what's the industry's contribution to this? The industry is about 65 to 70% of the emissions. So measured in billions of dollars at the expected social cost per ton, it's $9 billion. If we're up at the 8 times expected, the $3,300 per ton, it's $70 billion every year if the timber industry continues to behave as it has in recent years. And that means that the industry's social costs, just on the industry's 6 million acres, is perhaps as many as 7,000 deaths or more. Now, I would appreciate it if you would not go away from this and say that Ernie said that the timber industry is killing 7,000 people a year. Because this is all statistical, it's all probabilistic. We can't take the molecule of carbon dioxide coming from a particular tree and then trace it to somebody who was killed. So these are all probabilities, these are all expectations, so that's why the equivalent is in quotation marks. And let's put it in a little different scale. A log truck. So every time that you see a log truck, it carries emissions that will impose costs of at least $18,000 and perhaps $140,000 per truck. And by the way, the logs on those on each truck is probably worth, the logs are probably worth about $5,000. So this is a tremendous money generator for the owners, for the corporate owners, but it's a tremendously bad deal for society as a whole. And there are the equivalent deaths. That it will take 500, every time you see 550 log trucks, you're getting at least one death. And maybe it only takes about 70 on the far right log trucks to generate one death. And it may be only 7 if you're using the IPCC's numbers for the value of human life. Okay, well, I wish that I had another pretty picture that didn't have a lot of clear cuts in it, but that's it. Again, if you have any questions, I know I went through an awful lot of this very quickly. Please feel free, absolutely free, to contact me. And now I'm going to turn this over to Chandra. Thank you very much.
Okay, hello everybody out there. On that cheery note, Ernie. Hi, I'm Chandra LeGue with Oregon Wild. I'm our Western Oregon field coordinator in our Eugene office. I've been with the organization for about 16 years, working on forest policy and advocacy. What both Dominick and Ernie set up is, I think, a tremendous need for change in this arena. How do we take all of this scientific and economic information and turn it into policy and management solutions? So taking ideas like the natural carbon reserves Dominick talked about and making them reality through a variety of actions. So that's what I'm going to focus a little bit more on in my talk. So for most of Oregon Wild's history, we have focused on the protection and restoration of Oregon's forest lands. Environmental laws that we've worked to enact or defend, as well as public values, have ensured that some of these forests have been protected, mostly on federal public land, which makes up roughly half of the forested land in the state. Unfortunately, the majority of Oregon's public forest lands and their carbon storing potential that Dominick touched on have been carved up by clear cuts and roads. The other half of Oregon's forests are owned by the state or private interests or corporations and managed for timber production, contributing greatly to our local carbon emissions over the last century. So Dominick mentioned the incredible potential that our forests here in the Pacific Northwest have for storing carbon. And he also mentioned the many co-benefits of having healthy, intact, carbon-rich forests. And I'd like to just take a moment, because I love forests, to ground us in appreciating the clean water, the wildlife, habitat, healthy soils, and the amazing recreation opportunities that all come with the climate benefits of these intact forests and their biodiversity. All of these benefits will be impacted by climate change, but fortunately, these intact forests also are more resilient to climate change, offering a refugia of cold water, habitat connections needed for plants and animals to adapt, and trees and structures more able to withstand wildfire that we might see more frequently. So yes, there are numerous ways that forest management currently is contributing to the climate crisis, as both Dominick and Ernie explored, but there are also many ways that we can help forests be a part of the solution. So First, I want to acknowledge this first point, that reduce, reuse, recycle, getting back to the basics of the 3 R's. We need to acknowledge that we need to reduce our consumption of both fossil fuels as well as wood products, and to help those wood products last longer as part of the solution. Demand for these products is a big driver of this problem. Next, and these next 2 things I'll explore in more depth. We need to plug some of the leaks in the bucket that Dominic described, that are allowing carbon to escape our forests. And we need to mitigate our continued use of wood products that contribute to climate change. So I'll explore some of those possible solutions. In Oregon Wild's Forest Defense is Climate Defense report that was released a year and a half or 2 years ago, we identify how public forests can be a part of the solution in a few main ways. So I'm going to talk first about our federal public lands, that half of Oregon's forests. The first way is that we need to cut logging on public lands significantly. Public forest lands are currently a carbon sink, but only because of a reduction in logging that has occurred since about 1990. About 500 million board feet of timber is still produced from public lands in Oregon each year, and those levels are set to rise under the Trump administration's direction. They should instead be going down if we want to manage them for carbon and a carbon reserve. We should be practicing pro-forestation, which is a fancy word for letting forests grow, as a solution to climate change. And this will also help maximize all those other co-benefits that we've been talking about. Another solution is to protect our last intact wild lands through means like wilderness designation. Only Congress can designate wilderness under the Wilderness Act. And wilderness protection means that logging and additional fragmentation of the landscape is off limits. Currently, only 4% of Oregon is designated as wilderness, but most of that, 80%, is forested and quite carbon rich. For example, the newly designated Devil's Staircase Wilderness, which is a personal favorite place of mine in Oregon, is 26,000 acres of protected forest in the carbon storing stronghold of the Coast Range. So in this image, you can see the dark green, which is storing more carbon, and the purple outline being the Devil's Staircase Wilderness. Comparatively, all the bright white, which is not storing much carbon at all, is on industrial timberland. There's a lot more potential to protect these intact forests. There's about 4 million acres of large blocks of forest that remain in Oregon, and that we could be protecting in this way. The third solution for public lands is to hold the line on forest protection that we already have. This means maintaining protection with environmental laws and policy that we currently have in place for clean water, for endangered species, for our roadless areas, for old growth forests, in reserves, and along streams. All of these, in addition to public process to influence these policies, are under attack by the Trump administration, by the way. And so there's a lot of work to be done in holding the line on these protections. And finally, a last thing that we could be doing on our public lands is restoring our forests through ecological forest management. On the forests that we've already logged, which are hundreds of thousands of acres of public lands, the oversimplified, dense tree plantations that have replaced diverse forests need to be allowed to grow so that they can fulfill their potential for providing a livable climate, as well as all the co-benefits. And utilizing natural processes like fire and fire adapted ecosystems to restore natural structures and biodiversity. Now, restoration may mean removing small trees that have grown in due to fire suppression, or in plantations where we've replanted these dense crops. But we need to acknowledge that there are carbon trade-offs for any form of logging, including restoration. So we need to be able to carefully weigh those with any possible benefits. Shifting to the private and corporate timberlands side of the equation, the other half of Oregon's forests, we absolutely have to acknowledge that current laws in place in Oregon are failing us, both on the climate front and on providing clean water, wildlife habitat, and these other benefits. We have to start with modernizing Oregon's logging laws that allows this level of clear cutting that's contributing to all of the issues that that Dominic and Ernie talked about. With those changes and through other means like incentives, we need to be encouraging more climate smart management and production of wood products. So allowing forests to grow longer in between harvest rotations means that there will be more stored carbon and less of a deficit with each logging rotation. Leaving more trees, both in general and along streams specifically, will help with both water quality and wildlife habitat, in addition to storing more carbon. And then, phasing out the use of chemicals in forest management will enhance biodiversity and help with carbon storage as well. In addition, we need to be looking for wood products that are grown and harvested responsibly following these climate smart principles. Right now, there's a lot of small producers that practice these principles and get their logs to market. Mostly they're small, but if there are more incentives to join legitimate certification systems like Forest Stewardship Council, which is not perfect, by the way, but definitely has a lot of good provisions for allowing for more sustainability, then we're likely to see more of a market for these good wood products. So outside of the recommendations advanced in Oregon Wild's report that I mentioned, I wanted to bring up a few emerging opportunities for elevating forests in climate policy and vice versa that a variety of groups are working on, and I'm not as much of an expert on. But I wanted to bring them up because I feel like a lot of people are talking about these things, and there's a good amount of potential. So the first one is Governor Brown's executive order on reducing carbon emissions, which came about earlier this year after the failed legislative session. It directed all of the state agencies to figure out how they could reduce their carbon footprint, essentially. And the Oregon Department of Forestry has the possibility of putting forth proposals that could support reform in forest practices to reduce carbon emissions. There needs to be a lot of encouragement in this. There's the potential for exploring things like carbon markets and also supporting the Oregon Global Warming Commission's work through that executive order. So there are groups working to influence that process. There's a lot of talk about a Green New Deal. And as proposals come together for either national or more local policies in this arena, we need to make sure that forests are included and that we're investing in protecting and restoring forests as a climate solution as part of any Green New Deal. This is going to benefit human health, the economy, and have huge impacts on all the environmental benefits like clean air and water that we get from forests. There's also the potential to explore things like carbon markets out there, which I don't personally know a ton about, but seems like something to explore. And then finally, there's an opportunity with the Elliott State Forest. As a management plan takes shape for this 96,000 acre forest, almost half of it, which is unlogged, there's an opportunity for research on climate smart practices, on exploring carbon markets, and to protect the native forests there that are already storing so much carbon. Okay, with all these possibilities, I guess the big question is, why aren't forests being better incorporated into climate policy and solutions? Maybe it's obvious, but really it's simple. We are up against a lot of resistance to changing policies and laws that apply to forest management here in Oregon, because it confronts head-on the ingrained notion that our economy depends on timber and that timber production is good for the climate. And both of those things are false. So we're up against big corporate budgets, all the corporations that own much of Oregon's timberlands, you know, in many ways value profits over the communities and the long-term health of the planet. There's big money in timber industry lobby groups that go to Salem and Washington, D.C. and exert influence. There's a lot of misleading information out there. Ernie described some of the misinformation campaigns already very well. But how many times have you seen ads showing happy little trees and touting how well Oregon's forest laws protect our water? On Facebook alone, timber industry lobbying and education groups have spent hundreds of thousands of dollars in advertising in the last couple of years. So there's that. And then, of course, there's elected officials and the Trump administration working against environmental protection and climate science that we're all pretty familiar with. And finally, there are a lot of false solutions being offered. And some of these have already been covered. I don't need to go into them in depth. But the notion that we need to log more to reduce wildfires because wildfires spew all the forest carbon into the atmosphere is being tossed around, and proposals at the state level as well as federal are proposing this push to spend a lot of money essentially on logging to reduce fires, when the honest truth is fires don't actually release that much carbon in the atmosphere, and there's a whole bunch of issues around why fires are important. Storing carbon in wood products, Dominic went into this. There's actually not very much of the original tree that's stored in wood products. You know, the idea of new wood building technology is being lauded as being less carbon intensive. But how green is it? It's still coming from clear-cut practices, so it's still part of the problem and not a solution. You know, ideas like burning biomass for energy to replace fossil fuels, also not a good solution. And then political distractions like the Trillion Trees initiative advanced by the Republican Party recently doesn't address fossil fuel use or carbon emissions from continued logging. So we need to steer clear of those false solutions in order to make some headway. So again, on a bummer note, like Ernie, I'm going to wrap it up there. In essence, I'll just offer that we can do better. There's a lot of solutions, real solutions out there that we can incorporate our forests in through policy work and advocacy. And so I hope you'll all join us in working to do better.
All right, thanks, Chandra. We're going to bring back the panel. Get everybody unmuted here and dive into some questions. Okay, Dominic and Ernie, you should have a request for your webcams.
I'm back.
Okay. So I've tried we got a bunch of questions, so I've kind of tried to group them because some of them were a little bit, they overlapped. One of the things that came up a couple times was how ecosystem conditions are going to change because of climate change. So the areas where Doug firs are going to be growing, and how thinking about how those can be used as carbon storage, or changes within the timber industry itself, how climate change is going to impact, you know, some of the policies that we're thinking about.
Yeah, I guess I could feel that one. I actually published an article, I think it was in 2015, on using the downscale climate projections of that time. There have been newer iterations since then. But what we concluded is, first we looked at the entire Pacific coastal rainforest biome, from the coast redwoods all the way up to British Columbia and Alaska, coastal. And what we found was, based on the model projections looking into mid to late century, the southern terminus of the Pacific coastal rainforest biome is going to get hit the hardest. in terms of climate impacts. As you move further north into BC and Alaska, that's going to serve more as a climate sanctuary because you've got the moderating effect of the coastal maritime environment there, and the climate change events aren't as extreme as interior Alaska and points further south. So if we're looking to save biodiversity, as much of it as possible, in a quickly changing climate, the velocity of climate change is going to be much greater in the southern extent of the rainforest belt compared to the northern extent, which could serve as a climate sanctuary. So what we need to do in addition is within those areas that are changing more rapidly, like the southern extent, is we've got to identify micro-refugia that allow those conditions to be as stable as possible as the surroundings change. And we know that the best conditions for those refugia are old forest. They tend to be cooler. I mean, take a hike in the summertime in an old growth forest and then go out in a clear cut. There's a huge difference in temperature, precipitation. So this is all climate refugia property. So saving those old forests buys us time to allow those systems to adapt to the change ahead. In addition, lowering the stress load on those ecosystems allows them to adapt to change. The more stress, the more cumulative impacts, the more we tip those ecosystems into a different dynamic state with a lot of surprises. For instance, the projections for the southern extent of the coast redwoods are pretty dire. And what could happen is a more subtropical ecosystem takes hold in that place compared to in Oregon, which has a very small pocket of coast redwoods that are most likely to survive the current climate chaos because of micro-refugia properties. So we need to start planning our reserve network with the concept of refugia, connectivity, and reducing ecosystem stress loads from anthropogenic sources.
Yeah, may I comment on that as well? We also have to change how we view risk and how we as society interact with corporations. Right now, corporations get to log unless we can somehow, Chandra's organizations or whatnot can somehow intervene and demonstrate that there's a reason for them not to log. What Dominick is talking about, what I was talking about, what Chandra is talking about is that increasingly climate change poses an extreme risk to our future. And activities that increase that risk should bear the burden of demonstrating that they will not do so. So the burden of proof has to shift from us to stop them from doing things that will make things worse to them, where they can do things only if they prove that no, they're not going to impinge on the refugia that Dominick's talking about, or that they have mechanisms in place that somehow are going to compensate for their adverse effects.
A question for you, Ernie. Can you talk a little bit about how the social costs, you had a number of numbers there, how those are calculated, what's involved in those, and how you kind of come to those calculations?
Yes, if you look back at my original diagram, which goes from log trucks to carbon dioxide to global warming, climate change down to damages. Each part of those is supported by a model that tries to anticipate what the future is going to look like. So what is the economy going to look like and how many logs are going to be produced, for example? How much carbon dioxide is going to be produced in the future by an economy that is growing or not? And then how is the climate and then how are ecosystems going to respond? And then as ecosystems respond through rising sea level or through fires and droughts and insects that affect crops and the like, we have models on what are the costs that are imposed on human society. And then what happens in these processes is they integrate all of those models and run them about 10,000 times. Each model has a probability associated with it, and so every time they run it, the probabilities will vary a little bit. And sometimes all of the variables will go very high. Sometimes all the variables will go very low. Most of the times they're going to go right in the middle, that expected value that I talked about. And so that's how it works. It's a modeling exercise. It's probabilistic, and it gives us a range of values. And what is important right now is that the science has changed to tell us that the models from even a short time ago are out of date, because we are getting increasing evidence that it's going to be worse than the expected value.
Do any of you know about any countries or other governments that are using a social cost of carbon to protect forests?
I believe Great Britain is doing so. Europe is certainly using the social cost of carbon to make an awful lot of decisions. I'm not sure that they're using them to protect specific forests in specific locations, but increasingly Europe is saying we are making decisions, and if you must integrate the external costs that you impose on society, not just the profits that you are going to generate for your corporate owners.
Chandra, you say that fires are not a big carbon loss issue, but they were a big chunk of the chart that Ernie showed, almost as big as transportation. Can you two explain that?
Well, yeah, I definitely didn't mean to imply that they're not a source of carbon emissions. But when you look at how much carbon is in a forest, and then how much is released through fire, it's not very much proportionally. So you would lose more carbon from a forest that's logged, for example, than through a fire. And Dominic, I know you know about this stuff too, but does that fit?
Let me interpret the diagram. The diagram, the colors are a little hard to see. Fires, in fact, are 4. Timber is 35. The other color that looks like maybe it is fire is residential and commercial, and that's 21. So in fact, fires are a small, maybe about 4% of Oregon's total.
Yeah, let me chime in on that, because I was involved in the Oregon Global Warming Commission report. That was one of Ernie's citations there on that chart. And we could toss around numbers, and that's really important. Ernie's spot on with that, and Chandra as well. But when you think about it, when a big fire goes through a forest, let's say it's a severe burn and all the trees are dead in that patch, the carbon didn't go all up to heaven at once. In fact, the carbon transferred out of the living pools into the dead pool. And only a fraction of that carbon was volatilized, the living material in the forest, the needles, the leaves on the ground, the duff layer, the shrubs. They may have volatilized, but the vast majority of that carbon is in those dead trees and in the soil. Soils contain over 42%, I believe it is, of the carbon in a forest, and that carbon doesn't go away in a burn. Some of it gets volatilized. The vast majority remains in the soils for millennia. We don't have that with logging. We lose carbon in the soils and logging. So when you see that big puffy cloud, when these big fires are occurring, most of that is water vapor. Very little of that is carbon. And I think that's the misperception, that we've got a big problem with forest fires. Now that could change with climate change, as we're seeing in places, such as the boreal in Russia, and we're seeing in the tropical rainforest in Amazonia, which are human-caused fires. But by and large, the fires aren't the problem right now. The problem is logging at scale. So you got to compare these at scale. So an individual logging unit may not be as big a deal as a big fire, but when you look at the logging that is occurring over large landscapes, especially thinning that's been proposed to influence fire behavior, you're going to be putting out a lot more emissions than from the forest fire. And this is based on empirical evidence and models and studies that have been done in Oregon and other locations by Bev Law, Mark Harmon, and others.
Ernie, can you talk a little bit, or anybody who has some information on this, about the differences between, for example, extending the rotation time on private lands logging or even public lands logging? Like, what is the economic impact if you were to take a rotation time from 35, 40 years out to 80 years or 100 years?
That's a really excellent question. And yeah, there has been some work done on that. Particularly some economists looked at the industrial lands in California, Oregon, and Washington and estimated how much additional carbon would be stored on those lands if the rotation age were extended 5, 10, or 15 years. I took those numbers and integrated them with the estimates of the social cost of carbon. And what it comes up with is that if Oregon were to change its forest practices regulations so that on the 6 million acres of industrial lands, those owners would have to wait another 15 years before they cut. They could still cut, but every time they would have to wait an additional 15 years. That over the next 100 years or so, the accumulation of carbon would be enough that at the upper end, the 8 times value of the social cost of carbon, the total benefit, the total savings from all of that additional carbon over 100+ years would be almost $1 trillion.
Yeah,
It's a massive effect.
If I could just jump in on that, I think what's really interesting about that question, and Ernie did a great job of addressing the economics there, and I'm not an economist, but I do work on carbon offsets. And, you know, we're not going to save the climate by going 5 or 15 years out, or even 100 years out, but we might be able to get some really cool conservation done. And it's that delta between the status quo forestry operation and the additional carbon stored over, let's say, 100 years, because that's a more legitimate time frame. That difference has an economic value to the landowner. And that difference should be compensated for through some sort of incentives mechanism that would pay that landowner some money for keeping the trees growing carbon. So what we're talking about is a new dynamic here, a new paradigm in forestry. It would be carbon forestry or natural climate solutions forestry, and it would be a lot different than the industrial model, and carbon would be an asset that has value, at least as much value as logging the trees for wood products. If we can get it to that point where that carbon has equivalent economic value, you're going to see a lot of interesting conservation deals struck for climate and biodiversity. And I think that's where it needs to go in Oregon. I was a bit disappointed with my role on the governor's task force and the report that just came out. I think they could have gone a lot farther in encouraging the development of that marketplace so that we could see more non-industrial private landowners taking advantage of that delta and pretty much equalizing the playing field for more conservation and climate benefits.
If I may, another way to think about this as the economist, there's a new paper coming out of the UK now that is looking at the economics of biodiversity and the importance of nature, the value of nature. The lead author is a very highly respected economist named Partha Dasgupta. And what he reports is that when we improve nature, if we invest in making nature better or stronger or protect it, the return on that investment is at least almost 20% per year. Whereas investments such as let's invest in a new mill or a new log truck or new chainsaws, the industrial model, on average, those activities that degrade nature yield a rate of return to the industrialist of about 5%. So that's another way of thinking of very quickly getting a return on an investment by making nature stronger, more resilient, more able to handle and reduce the effects of climate change.
That's exactly the sort of research that needs to be incorporated into things, any concepts around a Green New Deal, because it is about, there are plenty of things for people to do to help realize those benefits. Yeah, and so, through employment and restoration, as well as, incentives for protecting forests, growing them longer, et cetera.
Thinking about some proforestation or reforestation efforts, Chandra, you talked a little bit about how just going out and planting a bunch of trees isn't necessarily the solution, but what can people do if they want to go out and plant a tree? Is it taking a native, like a non-Douglas fir out and finding a place for it? Like, is there a role in this conversation for some of these citizen activist groups that want to go out and plant trees? What is the best way to go about that? Or is that even useful at all?
Oh, there's always room for more trees in the world. But yeah, that's a great question, because yeah, it can feel a little hopeless, against this big machine we're working against. And planting a tree is something that anyone can do. So I think the important thing is to do it, for the right reasons in the right places, not just to cut them down again in 20 years. Thinking about where they will do the most good, replanting a floodplain that had, that had been turned into a pasture is a great place to plant trees, because you're going to be shading streams and providing fish habitat and getting all these other benefits from a mature tree that grows up over the next, 80 or 100 years. And there's, watershed council groups and others like that are specifically focusing their restoration efforts, including tree planting in places like that. So you want to make sure that it's lasting. If it's in your backyard and you plan, for that tree to grow for, as long as your house stands, that's a really great thing to do as well.
Yeah, if I could jump.
It can be a substitute for, driving more and and continuing to log the same way we do. It has to be in combination with those other efforts.
Yeah, and just to add the science to what Chandra just said, which was excellent from a heartfelt standpoint, the science is there to back you on this one too. So if we were to move to a natural climate solutions / carbon forest model, and through improvements, we would be able to secure 37% of the mitigation necessary to keep the climate below the 2 degrees centigrade tipping point at a 66% probability of success. That's what the science says. Now, in order of priority, what that means is, number one, you protect the primary forests, because the stocks are the most important part of the carbon ledger. It's not just the sink, it's the stocks, keeping the carbon in the existing forest, followed by proforestation, allowing those forests to accrue carbon back to their original capacity. Afforestation, which is this example, in the right places. You want to be planting trees, maybe in fallowed agricultural fields. Reforestation, again, in the right places. We're not talking about clear cuts followed by 1 trillion trees. That's not the way to go. But all of these play a role, but they're in order of importance. There's nothing more important than keeping carbon in primary unlogged forest. That has to be the ground zero of any carbon solution that we get through natural climate solutions. And everybody can do their part. Planting trees is important, but there is a prioritization in that model of keeping the planet below 2 degrees centigrade, overheating.
Okay, well, a few closing comments out to the folks who are listening. This presentation will be made a video and emailed out to everybody. And if you're interested in individual presenter slide decks, please contact them. The contact information is on the screen right now. But I want to wrap up and give each of you an opportunity in order of your presentations to talk about something hopeful, because a lot of the presentations ended on a little bit of a downer. And I'd like the folks who are out there listening to have something positive to come away from this presentation with. Dominic, you're up first.
Sure, you got to pick on the guy here, the old guy here. All right, so again, because I work at a global scale, I'm seeing some pretty interesting things going on in Europe and in other countries that have now adopted primary forest language in their climate solution space. The European Parliament has been looking at this. We're seeing it with the COP20, which has now included primary forest in their climate solution space. It's happening internationally. I think there's an opportunity, especially if there is a sea change in November, hint, hint. If that happens, I think we need to kind of get this country back on the track of what we're seeing in other countries attempting to comply with the Paris Agreement. The best way to do that is by protecting the existing stocks. And the last hopeful message that I have is I am so encouraged by what I'm seeing as an uncontrolled experiment for the planet. I mean, the emissions have dropped some, the skies are clear. There's an opportunity now to move into a different dynamic with the planet that prepares us in a better position for the next pandemic. And I think it's happening, and I think it's the younger generation. I draw my strength from people like Greta Thunberg and other young people that we're passing the baton to now that are doing some amazing things, and we need to build off of that momentum.
Right, Ernie, you're up. Something hopeful.
Yeah, let me take another scale on this. I think I'm hopeful in part because I have seen the Oregon legislature fail to address the timber industry in any meaningful way my entire life. And what I hope is that over the last 2 years, the 2 legislative sessions, the timber industry so overreached by inducing Republican legislators to walk out of the legislature that at last we have a governor in whom I've been very disappointed, finally came out with an executive order instructing all agencies to do whatever they can to reduce greenhouse gas emissions. Now, the first response that we see from the Oregon Department of Forestry is again very disappointing, but this is at least a partial step forward. We at least have a framework from the executive order. We, as Chandra talked about, there are an awful lot of people, an awful lot of organizations trying to fit into that executive order and try to bring about meaningful change. If it all falls flat, then, well, I guess that's ending up on a sour note. But I'm hoping that we will see some meaningful change.
Cool.
Right,
All right,
Chandra.
well, I've got two short things. One is I see a lot of progress in forest advocacy and groups working more closely together with more traditional fossil fuel centered climate activist groups in combining our efforts and including forests in the climate change prevention, mitigation, solution conversation. And I think that's a big change from what we saw, even 2 years ago. So that's great. And then just in general, I think people are really waking up to the importance of forests in general and showing their appreciation by not just getting outside and going for a hike in a beautiful place, but then turning that into action and support for making change. There's a lot more people in Oregon now who value all these clean water and clean air and healthy bird populations and great places to hike than there are who think that forests should be used exclusively for timber production. And that, I think, is a very hopeful thing and something to help us build the movement.
All right, I want to thank our panelists for joining us this afternoon and thank everybody who stayed tuned. And again, we'll be sending this video around. There's contact information here for our panelists. Thank you all for listening and have a great day.
Thank you.
Live
Bye.
long and prosper.